Have you ever wondered why an airplane can soar through the sky, or how that racing car stays pinned to the track at high speeds? The answer lies in a fascinating principle of physics known as Bernoulli's theorem. In the mid-18th century, a Swiss mathematician and physicist named Daniel Bernoulli introduced a remarkable theorem. This theorem, now known as Bernoulli's principle or Bernoulli's theorem, has become a cornerstone in the field of fluid dynamics. To understand Bernoulli's theorem, we first need to grasp the concept of energy conservation. According to the law of conservation of energy, energy cannot be created or destroyed. It can only be transferred or changed from one form to another. This forms the backbone of Bernoulli's theorem. Bernoulli's theorem states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy. It's a principle that applies to the flow of both liquids and gases. To break it down, imagine a fluid flowing through a pipe. The pipe is wide at one end and narrow at the other. According to Bernoulli's theorem, as the fluid reaches the narrow part of the pipe, it speeds up and its pressure decreases. Conversely, in the wider parts of the pipe, the fluid moves more slowly and its pressure increases. This might sound counterintuitive. After all, wouldn't you expect the pressure to increase as the fluid speeds up? But remember, we are dealing with the conservation of energy. The total energy, a combination of kinetic energy due to the fluid's motion, potential energy due to the fluid's height, and pressure energy, remains constant. But now you might ask, what does this have to do with planes flying and cars sticking to the track? Well, that's where the magic of Bernoulli's theorem comes into play. When a plane flies, the shape of its wings, broad at the front and narrow at the back, creates a difference in airspeed above and below the wings. The air above the wings moves faster, creating a region of low pressure. Meanwhile, the air below the wings moves slower, creating a region of high pressure. This pressure difference generates lift, which allows the plane to fly. Similarly, in the case of a racing car, the design of the car body creates a Bernoulli effect. The shape of the car is such that the air moves faster over the top than underneath. This creates a low-pressure area on top and a high-pressure area below, literally sucking the car onto the track, which increases traction and allows for higher speeds. In conclusion, Bernoulli's theorem is a fundamental principle in fluid dynamics that explains how pressure varies with velocity and height in a flowing fluid. Its applications are diverse, ranging from the flight of an airplane to the design of a racing car, and even to the simple act of drinking through a straw. Bernoulli's theorem, though conceived centuries ago, continues to shape our world in ways we often take for granted. So, the next time you see a plane soaring in the sky, remember it's all down to a Swiss mathematician and the magic of fluid dynamics.